Need to extract structured data from language models while keeping your code clean and maintainable. We'll demonstrate how DSPy's adapter system handles the entire workflow, defining typed output fields, formatting the prompt with clear markers, and automatically parsing the model's response into ready-to-use Python objects, all with just a few lines of configuration. You'll even see the exact conversation history the LM processes.
Import DSPy. Import Pydantic. DSPy, configure, LM equals DSPy, LM, OpenAI/GPT-4o mini, adapter equals DSPy, chat adapter. Class Science News, Pydantic, base model. Text, SDR. Scientists involved, list SDR. Class News Cod DSPy, signature. Get news about the given science field. Science field, SDR equals DSPy, input field. Year, int equals DSPy, input field. Num of outputs, int equals DSPy, input field. News, list science news, equals DSPy, output field, desk equals science news. Predict equals DSPy, predict news ca. Predict, science field equals computer theory. Year equals 2022, num of outputs equals 1. DSPy, inspect history.
This code demonstrates DSPy's adapter pattern for language model integration, where structured Python signatures bridge the gap between programmatic requirements and LM capabilities. The key concept is using type-annotated classes to define both input parameters and expected output shapes, while adapters handle the conversion to LM-specific formats. What makes this distinctive is how it transforms free-form LM interactions into typed, contract-driven exchanges without manual prompt engineering. The pattern works through a clear separation of concerns. Your signature class declares the task's data schema and requirements, while the configured adapter manages all LM communication details. When executed, the system automatically formats inputs into the adapter's message structure, sends them to the LM, then parses and validates the response against your declared output types. This means your application code interacts with Python objects rather than raw text, with the adapter layer handling all serialization and deserialization. The practical advantage is reliable, maintainable LM integration that adapts to different models while preserving your application's type safety. By working with structured data instead of raw prompts, you eliminate common issues like malformed responses or schema mismatches. The adapter system's built-in validation and fallback mechanisms become particularly valuable when dealing with complex output structures, though this comes with a slight overhead in initial setup and response parsing. Let's break it down.
Import DSPy. Import Pydantic.
Imports DSPy for structured language model programming and Pydantic for data validation and model definition. This combination enables typed AI signatures with enforced output schemas in the code that follows.
DSPy, configure, LM equals DSPy, LM, OpenAI/GPT-4o mini, adapter equals DSPy, chat adapter.
Configures DSPy to use OpenAI's GPT-4o mini model for all subsequent predictions. The chat adapter standardizes the interface between DSPy and the language model's chat-based API.
Class Science News, Pydantic, base model. Text, SDR. Scientists involved, list SDR.
Defines a Pydantic model that enforces type validation for science news data. It requires each news item to have a text, string, and a list of scientists involved, ensuring structured output for the DSPy pipeline.
Class News Cod DSPy, signature. Get news about the given science field. Science field, SDR equals DSPy, input field. Year, int equals DSPy, input field. Num of outputs, int equals DSPy input field. News, list science news equals DSPy output field desk equals science news.
This defines a DSPy signature that declares the exact interface for AI interactions. Each input field specifies a required parameter with type enforcement, while the output field constrains the response to return structured science news objects. The signature acts as both documentation and runtime validation for the AI's expected behavior.
Predict equals DSPy, predict news ca. Predict, science field equals computer theory. Year equals 2022, num of outputs equals 1.
Instantiates a predictor from the NewsQA signature, converting the defined schema into an executable AI call. The subsequent invocation demonstrates concrete usage with positional arguments for the science field, publication year, and requested result count. This shows the complete workflow from signature definition to actual prediction.
DSPy, inspect history.
Shows the complete history of the DSPy prediction execution, including all intermediate steps, prompts sent to the LM, and raw responses. Essential for debugging when outputs don't match expectations, letting you inspect exactly what was generated at each stage. DSPy signature pattern. This example shows how DSPy signature combines with Pydantic models to enforce structured LM outputs, where NewsQA defines the input-output contract and Science News validates the response format. The num of outputs parameter in signatures doesn't automatically limit LM generations. You must handle this in post-processing. Always pair signatures with Pydantic models to guarantee type safety in LM interactions.
The schema that defines nothing holds all possible shapes.